do till Tuesday, which is another good reason that we've done a lot of work in this section. Another good reason that I didn't necessarily need to totally be like, everybody turn off your feelings, let's do math. Let's not. Let's feel, let's talk, let's love, and then, okay, let's do a little bit of math, because I do want to help you on the ones that are going to get tricky, yeah? KJ was gone yesterday, and he's like, what'd I miss? Yeah, kind of, but not the trickier examples we're doing today. But she did kind of miss the system. So can we walk him through the system? Like, there is a system. There is a way. There is an approach that we are going to tackle these problems with. And at least there is an approach. Like, praise Jesus, there's an approach. Like, okay, cool. And if we can get it down, maybe we can apply it to even the hard ones. So the approach is look at the fraction you're given and ask yourself, is it improper? When do we divide? Or? Bigger than or? Equal to, and that's the one that we're going to forget. That's the one we're going to forget. So Caitlin's right. We're looking at the top and asking ourselves the degree. Is it higher than or equal to? If so, do a big old polynomial division like the example that we did yesterday, where a fourth over a third, oh my goodness, let's divide. And when we divided, we were able to take away the degree that was missing. There was a whole linear x polynomial that was in there. And so we got to kind of take that guy to the very end and be like, hey, guess what? You're going to stick around to the very, very bottom, and x plus, you're a part of my answer. But that remainder had a fraction that was proper and could be broken down into smaller pieces. Now, I shouldn't go deep into life lessons because we've already talked a lot, and I'm sorry if that was hard. But in general, I mean, you can think of this big old fraction on top being a big old hairy problem, a big old complicated situation, and sometimes when big old complicated situations overwhelm, we just kind of need to break it down into smaller pieces and be like, okay, well, what about this? What about that? What about this? That's kind of what the calc kids really need this process of partial fractions for, is to take something messy that's been put together that sometimes it's helpful to look at it in this form for like horizontal asymptotes and vertical asymptotes and slant asymptotes. It is helpful to look at it all at once, but in other situations, it's much easier just to have it kind of broken down and say, okay, let me just focus on this for a bit. Okay, and let me just focus on that for a bit. And literally, that's what partial fractions let us do. Take something big and hairy and be like, oh, okay, there are little smaller pieces to it. So, Paige, that's kind of what we're trying to do, is take a fraction and break it down. We did see 2 days ago when you were, I think you were here 2 days ago. When you were here, there was this thumb trick thing that Jaden was like always wanting us to use yesterday. And if we can, we totally will. Just sometimes we can't. So hence why we had to learn more. And so this process says, try to divide when improper. With whatever is left, whatever fraction rational function is left, go ahead and factor the denominator as much as you can. And from all the factors, make partial fractions. If they're linear, they're going to look like this. If they're quadratic, they're going to look like this. If they're cubic, don't worry, none of ours will be. There would be a quadratic on top. If they were fourth degree, there would be a cubic on top. There are worse partial fractions than we're seeing. But kind of like God doesn't give us more than we can handle in the moment, or like if he showed us all of our sin all at once, we would just die. Like, we're just kind of exposing little bits and pieces. And yes, it's going to feel harder and harder, and yet, okay, just there's worse stuff out there. Hang in there, hang in there. We don't have to see the bad stuff. But the process, the really cool thing is the process is really similar, except systems of equations can get messy. We actually had a really nice example. And Alec, you told me it's already in stair step, right? Because he saw A equals 6, plug it in, we can find B. Plug A, B, and C in, we can find C. Like, oh my, well, we don't know C yet, sorry. Plug A and B in, we can find C. What we ended in was a stair step already, but imagine if it wasn't. There's an A and a B and a C and an A and a B and a C and an A and a B and a C, and now we have to, after all this work, do the stair step? They can get long. They can get long. They don't have to be, but they can get long. And because of that, I was trying to be like, well, there technically is this really cool zero trick that isn't technically the system, but it's kind of what the thumb trick is based on. So even though our system was nice, and even though our system we had an answer, we could plug in and find another answer. We could plug those in and get the third answer. If the system is uglier than that, maybe it would have been smarter to stop way back here when we first multiplied. Alec, thanks for helping me out on that. When we first multiplied to get rid of all of our fractions, maybe it would have been nicer to be like, okay, we can't do the thumb trick, but the thumb trick said plug in zeros. So let's take this and plug in zeros and see what happens. One of the zeros, oh, sorry, this should be a little bit down, huh? There we go. I don't even know. One of the zeros was x equals 0. One of the zeros of the original factors, this guy, his 0 is 0. So plug it in. Plug it in where? Plug it in x spot. So 0, 0, 6. Cool, 6. Plug in 0. 0 plus 1 is 1. 1 squared is 1. 1 times a is 1. A. Okay. But 0 is present in all the other factors, and it's going to cancel all those out. All of a sudden, a equals 6. And I never had to FOIL. I never had to distinguish between terms. I never had to make a system. Nice. But wait, we plug in 0, we get a. We plug in -1 and a, we get c. We plug in a and c, and wait a minute, we ran out of zeros though. We only had 2 zeros. We had 0, we had -1. What did I do next? You might not have known, but I said, well, I ran out of zeros, but I can plug in other numbers. Why didn't I plug in 199? Because it would have been so hard. Why didn't I even plug in 2? Because 1 was easier. I plug in the easiest x I can, given the 2 that I know, and all of a sudden, I'm only going to have that third variable missing, and I could go ahead and solve. And we ended up, I think, did we solve? And we were supposed to solve. Because I ran out of zeros. So at the very beginning, remember there are 3 partial fractions, but I only have 2 zeros, 0 and -1, because this guy is the same 0. That's why I can't do thumb trick. So I plugged in the 2 zeros, and I said, I only have 2. I can plug in any x I want. So I just picked another one. I just didn't want to pick something hard, because then it would take time. So I just picked 1. But if 1 was already taken, like say 1 was above, I would have picked -1 or 2. Is that cool? So it lets us avoid the whole system if it's gross. So let's go tackle something. Let's go tackle something. Is that okay? Let's go tackle something. I don't feel like writing words. You guys feel like writing words? Let's go tackle something. So, KJ, long story short from yesterday, there's a system, and then there are a couple tricks, and we're just going to do what we can to see how to tackle this one. So, the system says, is it improper? Why no? Gee, tell Alec. He needs some of your brain right now.
Oh, wait, there's a square on the bottom.
Square on the bottom, and what's on the top?
Wait, the cube on the bottom and a square on the top.
There you go, there you go. You were seeing it. It's bottom heavy, not top heavy. Oh, but there are 3 and there are 2. No. It's not about how much, it's about the degree. Who's stronger? Bottom. It's not top heavy. It's fine. It's fine. The degree on the bottom is bigger than the top. Okay. Shh. Sophia's especially KJ. Is it improper? No. Do we divide? No. Okay. So step 2 says factor. I won't even make you look back. Factor. Factor what?
Top and the bottom.
Not the top. Well, we could try to factor the top because if something canceled out, our life would be nice. Right? Yeah. But do you see that this only factors so far?
Why do you want that?
Why am I? Yeah. It's annoying. Because x squared isn't -4, it's +4. If it was -4, it'd be x plus 2x minus 2. But it's +4, so we're stuck. Alright, fine. So how many partial fractions are we going to have?
2.
Just? Why just 2? It is a cubic, and so sometimes it could be 3, but we could only get 2 factors, right? If we go setting this equal to 0 to find the zeros, to find the factors, we're going to get imaginary numbers. We're stuck. This is what we call an irreducible. We can't go any farther without going to imaginary numbers. Now, we know what's over here. This is what we're trying to break down. Let's not do the x cubed. We like seeing the factors because then we know what to multiply to the other side. Now, we can't do thumb trick. If we would, we could, but we can't because this is a square. Thumb trick is illegal if we have a power of a factor out here, or if we have a nonlinear in here. So, can't do thumb trick. Now, doesn't mean we can't use zeros. We'll try. On top of him is an A, and on top of him is a BX plus C. Now pause. We haven't seen one this messy.
Wait, why is there?
Exactly. Right? That's new. Why is that new?
It's not improper.
Yeah. It's not improper. When we go down, we either make linear factors or quadratic factors, right? And some of you, if flipping back is too hard, that's fine. I got you. If flipping back is too hard, remember when I did the shortcut version? Linear factors say, hey, it's an x to the 1. We just put a on top. But if it's a quadratic factor that I can't break down, see it? Because I need it to be proper, but that doesn't just mean a constant. I can also have a linear and still have it be proper. This one I couldn't have an x or else it'd be improper. I'd have a tied degree. I just have a constant, but this guy, all of a sudden, I can have a line on top. So then, coming back, we've set up our partial fractions. Name of the game is, fractions, so we get rid of them. It's nice in math. If you don't like it, you can do something to get rid of it. Sometimes. When legal. Because it allows me to only legally. Anyway, we're stopping. Come back. What do I do to both sides?
Multiply it by the x times x plus 4.
Yeah. This morning, HPrecalc started their system of equations substitution thing. And it was like, fractions. Okay, fine, get rid of it. There's a legal way to do that. Or I'd rather do elimination. Okay, I kind of let them do that. With you guys, it's a mess until we multiply both sides by. Now, depending on your skill level, some of you are jumping straight to what happens, and some of you are like, no, it's better safe than sorry. Totally fine. Be honest with yourself. Be honest with yourself. And if you need to, write it out, because then you're like, okay, whatever, I'm getting it right, and that's exactly the point. What do you need to get it right? Sorry, I'm not trying to make everything have a life lesson illusion. It's just happening, and I don't mean to. Yeah, I know, I'm sorry. It's not even on purpose. But here we go. Bx plus c. Sometimes it's on purpose. Equals. Okay. Why am I going to pull out not just the yellow? Oh, stink. I don't remember who was who yesterday. Was yellow the constant or the x? I don't know. Maybe he was the constant? I don't know. And then purple was maybe the x? I'm not sure. And then we went to pink. I know we went to pink for the other guy. We have 3 different types of variables. So we could set up the system by multiplying and setting up the system. Or we could do that whole zero trick and kind of do the cover-up method without knowing it's not going to perfectly work the whole time. The zeros method says, who are your zeros? Well, his 0 is just set if x equal to 0. What do we get? 0. But, what are his zeros? Close. Rad negative 4. Plus or minus, because it's an imaginary number. I'm not going to plug in imaginary numbers. But the problem is I have 3 unknowns. I need 3 plugins. So if I can't get it from square root of a negative 4, well, I guess I could get it somewhere else if you want. I just need 3 plugins. I just need 3 plugins. Now, some of you just heard me say, that guy's a 0, these guys aren't. Which means, and if you want, you can just kind of like, just pause and think as I plug in. If I go plugging this guy in, I would plug in 0 to all the x spots. So 0, 0, 4. And then 0 plus 4 is 4, 4a. It's going to be there. 0 times b is 0, plus c is c times 0 is 0. Oh, that's nice. Hey, look, a is equal to 1, because divide by 4. But then, when I go down to these guys, I'm not going to have any zeros anymore, because I don't have any other zeros. Zeros make things nice, because they cancel things out. But the other ones aren't going to work quite that well. Now, you can keep going with that logic. Plugging in a is 1 to this, and then plugging in x is 1. Maybe it would help you find b or c. Maybe it won't, but it'll give you an equation with b and c. Then you do the same thing. A is 1 and x is 2. Maybe it'd help you find B or C, or maybe just an equation with B or C, but then you just have a little system of B and C's to solve. Or if you're like, I don't like it if there aren't zeros, you could have technically always come over here and been like, let me go the old school way. And the old school way, now I'm not saying which one's best, I'm just trying to let you know your options. I'm trying to let you know your options. Yeah? When I come over here, I can match up and say, okay, who's squared? Because any squared guys would combine to make this 3. So he's a squared and he's a squared. So I can say that A plus B, anyone that's with the squared terms will make the squared coefficient of 3. Anybody that's with an x term will make the x coefficient of 4. And anybody that's without x's is going to make the without x's. Oh, wait a minute. Was this system really all that bad? Sometimes the systems are good. Sometimes they're not. Because Alec, I mean, this one's even kind of better than a stair step in the sense that I already know 2 answers. I just need to combine the person. But I had to say, who doesn't have an x? You're making the 4. Who does have just an x to the first power? You're making that 4 coefficient. And who has squareds? You have to combine to make 3. But if you're like, well, sometimes that's bad though, so I want to know the zeros way. Okay, well the zeros way would have, remember, taken this expression right here and just said, now it's time to plug in. We did plug in x is 0, now it's time to plug in x is 1 and then plug in x is 2. So if we plug in x is 1, that would be 3 plus 4 plus 4 equals a. Wait a minute, we know a is 1. Sweet. A times 1 plus 1 squared plus 4 is 5. Plus b times 1 plus c times 1. I mean, this is good and all, but that's 7 and that's 11, and then minus 5 is going to be 6. 6 equals b plus c, but I don't have an answer. But I had to plug in 3. So plugging in 2 also. 2 squared is 4. 3 times 4 is 12. Remember, I'm plugging into the x spot. 2 squared, 4, 4 and 3 is 4. 2 times 4 is 8. My mental mathers, this isn't bad. My non-mental mathers is kind of brutal. 2 squared is 4, 4 plus 4 is 8.
Just mental.
Okay. It's a little scary, but okay. 2b plus c times 2. We'd end up with 20, 2b plus c. I'm plugging in b times 2 plus c times 2 because x is 2. Oh, I thought you had a question, Sophie. You're good? Oh, apparently you. I'm making up stuff. 24. Oh, wait, we know a is 1. I forgot. A is 1. So, wait, we can do 24 minus 8, which is 16, equals 4b plus 2c. Okay. Pause and just think. Pause and just think. If this had been nasty, A, B, C, A, B, C, A, B, C, ugh, go get a stair step. Wouldn't this be easier? 2 equations, 2 unknowns. Like, if that had been its worst, like with A's and B's and C's, every single equation, I have to take 1 and 2 and get 4. I have to take 2 and 3 and get 5. I have to put 4 and 5 to get, like, if we had to do the stair step, I like this better. It's 2 equations, 2 unknowns. All I have to do is, I don't know, like an elimination, maybe multiply this guy by, what, -4 or -2 or something? I could take these 2 equations a lot quicker than doing that nasty system. But once again, was this a nasty system? No, but please just realize in homework, it's not about doing it the fastest. I mean, cool, we'll give like, you did it faster on Tuesday, but in reality, you're just trying to get it right. And what's up? Huh? No, you're good. Because you're keeping it balanced, so you're keeping the equality state. Actually, that would have been easier, because then you wouldn't have to multiply, and you could just, subtract the second one? Or subtract the first one? Yeah, it would have been easier. But just because we have like the answers right here, we just grab them real quick. So A is equal to 1, C is equal to 4, and 1 plus what is 3, B is equal to 2. And so however you do it, at the end of the day, whether you're going that way, finding B and C, knowing that A is 1 in both of them pretty quickly, or whether you're actually doing a little system and like color coding, or at least like thinking through like the squared and the x and the constant, you end up with what was all put together a single rational function being able to be written in its individual partial fractions or its pieces. So 1 over x plus 2x plus 4 all over x squared plus 4. I know some of you were like, can you factor out a 2? Definitely. You can make it 2 times x plus 2. That's fine. But these are the fractions. These are the only fractions that could have multiplied to make that beginning one. So still a little messy, but not near as messy as it was before. It's a linear over quadratic instead of a quadratic over cube. But that's as much as we can break it down because this guy doesn't break down anymore while staying in the real numbers. So 2 different options, 2 different methods, both of them valid. Just sometimes, ironically, I mean, this system was kind of the easiest, except usually if I have ABC, ugh, I have to stir step it like section 7.3. I have to stir step it. And the zeros might be easier. In this one, the zeros just happen to be a little harder. Except if we did what Em said, and she was like, hey, you can just pull out the 2. Not with that voice, I did not mean to say that you sound like that. I apologize. But yeah, we totally could have just pulled out that 2. And if we had pulled out that 2, then we would have had an 8 and a 2b and a 1c. And then we could have just taken that guy and subtracted this guy. The c's would have canceled. I would have had b minus 2b. Negative b equals negative 2. 1 subtraction. B is 2. Plug in. C is 4. Is C 4? Yeah, C is 4. Maybe take a peek at another one, just to have an idea. How is this guy even different? I'm just trying to show you different ones. Just would you know what to do? What happens if we have something like this? Okay, I'm here in FOIL. Is anybody thinking divide? Yes! No! It's not improper. What's the degree of the bottom? Okay, so maybe none of you thought it. Some people have in the past. The cubed and the squared. Not improper though. It's a 4th degree, so okay, no bottom one. Don't divide. FOIL, I like the idea as far as it could have been FOIL to begin with, and you might have factored, but remember, we're needing to factor for our partial fractions anyway. So you can think FOILing to know that it's a 4th degree to not divide, but I wouldn't FOIL. I think I would just, it's factored. I think I can just start, right? Because of that plus, I can't factor it anymore. If it was a minus, I could totally factor. It'd be gross. It'd be plus root 2 minus root 2. But no, the plus, remember, the zeros are imaginary. It can't go anymore. My question is, how many partials?
2.
But how do you make them? There's only 1.
You just take them apart. It's a square.
No,
No, it's a square. It's already just 2.
it's the, yeah, there's a 1 and there's a 2. Remember, whenever we have a factor raised to a power, we have to make a partial fraction for each power building up together. If it was a cubed, I would have 3. I'd have 1 and then squared and then cubed. If it was a 4th power, I would have 4. 1 squared and cubed and 4th power. It's just whatever I have. And here's the bummer though. Alec, is that a linear or is that a quadratic? So can I just put the A up top? And then I have to do the for both of them. They're both quadratics. You see it? Like to see why we need to do it. I know you're not excited about it. I get it, but I'm here. We're doing it together. It's just like what could happen. But pause. Even if it looks gross, what's your system? Come back to the overarching. Even when it's gross, we're still going to multiply. And when we multiply, we're going to get an expression that we're then going to, I know some of you mental mathers, maybe you're going straight to your others, write it up. But when I multiply, only one of his is going to go away. So I'm going to have this guy. And I'm going to have, oh, but wait, both of his will reduce away. So I just have, it's up to you, except this time I would need 4 colors. 4 colors, but, oh. Wouldn't I have a constant that's technically a 0? An x term that's technically a 13? A squared term that's technically a 0? And then a, oh, think now what? Maybe it's one of these purple. Ooh, a teal. And then a cube term, that's 8. I would technically have 4 equations with 4 different types of terms that could come from, what do you guys think of one? And then we could just go ahead and say, hey, who's a cube? Hey, who's a square? Hey, who's that? Now, some of them are 0, so they might not be that. But remember, if you don't like that way, you could just plug in 1, 2, 3, 4 different x's. X is 0, x is 1, x is 2, x is negative 1, 3, 10. I don't know. Plug in 4 x's or color code 4 different colors. I'll see you guys on Tuesday. Thinking of you, love you. Happy 3-day weekend. Hope Monday allows you extra time, an extra break from the craziness that is the school day.